Good. Okay. So then let's start this lecture. We have entered a new chapter, which is about integral ring extension. And I already explained you that this is a generalization of the notion of algebraic extension. So let me recall the definition. So if A is a subring of B, these are rings. So one is subring of the other. And then we have taken element x of B, and we defined what it means for x to be integral over A. So this means it satisfies a polynomial equation which is monic and has coefficients in A. So it means the following: there is such an equation. Okay, the coefficients are in A, and this is monic. So here we have the coefficient 1. Okay, good. So, and then in order to deal with this, we proved some proposition which is very important, and in the end it relied on Nakayama's lemma. It gives us, say, how can we characterize this in a nicer way? And then we showed that if I have such an integral element, then I look at the subring of B generated over A by X. And we proved that this is an integral. Okay, this is a finitely generated A module. Okay. And we even showed the following. Okay, maybe I can say it this way. X is integral. So it's an if and only if. F is integral over A if and only if I have this. Okay. And for the purposes of proofs, so one direction was not trivial and it relied on Nakayama. So for the purposes of proofs, you can even replace this by something a little bit more general. So maybe you have a ring C intermediate. So it's between AX and B, and C is a finely generated A module, and then you also have this. Okay, so this is this characterization. Okay, I'm going to use in the following several times. Okay, so this was a repetition. Okay, now let's move on. So what I want to show is transitivity of integrality. Okay, there is something happening here in transitivity. So it's like, you know, from field theory, if you have one algebraic field extension, then another one, then altogether it's algebraic. And I want to prove the analogous statements in this ring setting. So let me start with the following corollary, type 2. What's that? So I have a ring extension, A to B. Then I take a finite collection of elements, x1 up to xn in B, which are integral over A. Okay, and the statement is then the ring generated over A by these elements. So I denote it this way. So it's not a polynomial ring, it's just a subring generated by these elements. This is a finally generated A module. So what happens is just this characterization I put in the box above, this one, okay? This one, finally generated, is now extended to adjoining several elements, okay? So how does this proof go? So I do induction on n. And the case n equals 1 is, this is the proposition 5.1 from last time, which I just recalled. So this we know. Now let's do the induction step. So let's assume n greater than 1. So then I use induction hypothesis. By induction hypothesis, okay, a to the m minus 1 is a finally generated A module. Okay. So on the other hand, I can write an as an minus 1, and then I adjoin xn. Okay. So now let's see. I know, okay, I know the xn is integral over a. So in particular, xn is integral over the larger ring an minus 1. Right. And then I can apply my proposition. So again, it tells me that an is a finally generated an minus 1 module. Okay, I say again, Sxn is integral over this larger ring an minus 1. Okay, so now you see I have this. Okay, what is the situation? I have A contained in an minus 1 contained in an. So now I showed that both of these extensions, I mean, what do I say? This is a finally generated A module. An is a finally generated an minus 1 module, and then therefore by transitivity, this is the transitivity. Transitivity. This was the proposition 216, which I treated last time. This implies an is a finally generated A module. So this is just the transitivity of being finally generated. So I have proved this. So let me turn on the light over there. Light is already on. So I have now a smaller window with less light. So where did I put my pencil? Somehow I put my pencil somewhere, but I don't remember. My God. This is all on the video and I cannot find my pencil anymore. Maybe that's on the floor. Really incredible. Really funny. So what did I do? I turned on the light. Not in my pocket. This is impossible. Disappeared. This is impossible. I mean, how can this be?
Maybe you have to check the recording and look where you put the pencil on the recording.
That's a very good. I stop the recording because that's ridiculous.